Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at a special type of distribution, the triangular distribution. And we'll use this to calculate probabilities. So you usually use this when you don't have little data, but you know that there's a range of values and you know a value that is most likely. Probably doesn't make much sense. Let's illustrate with an example. So let's say the time taken to complete a task is between 2 and 10 seconds, and most often it takes 6 seconds. What is the probability that someone takes between 3 and 7 to complete? So what we're going to do is use a triangular distribution, because in here we've said that 6 is the mode. It's the most likely value to occur, and it takes between 2 and 10 seconds. So we're going to draw a triangle that looks like this. This will be our PDF. So this is preferable to, say, the uniform distribution, because that would be a straight line. That would mean you'd have the same chance of taking 6 seconds as you do 2 or 10 seconds. But what the triangular distribution allows us to do is have a mode, have a clear value that is most likely to occur. So as you can see, most people will complete around 6 seconds, few will complete in 2 seconds, and few of them will take as long as 10 seconds. Now, because this is a PDF, the area under this curve, in this case it's a triangle, must be 1. This area I've shaded has to be 1. So the area of a triangle is base times height over 2. In this case, the base from 2 to 10 is 8 units. So we have 8h over 2 is equal to 1. Dividing 1 by 8 over 2 gives us h equals a quarter. So this value over here must be a quarter, so that the area under the curve is equal to 1. So how are we going to find the probability someone takes between 3 and 7 seconds? We can't do this without knowing what the PDF is, without having its equation. So here the PDF is made up of 2 lines, one here and one here. We need to find the equation of each of these lines. So let's start with the blue. So this is a line that passes through 2, 0 and 6, 1 quarter. So we're going to find its equation. Now remember, the equation of any line is y equals mx plus b. You just find m and find b. So in this case, m, the gradient, is y2 minus y1 over x2 minus x1. It is 1 over 16. So now to find b, we take our equation y equals mx plus b, we substitute m for 1 over 16, and we substitute x and y from one of the points. This one's probably easier because it doesn't have any fractions. So I'm going to substitute x for 2 and y for 0. So solving this equation should be very easy. 2 times 1 over 16 is 1/8. I get b is negative 1/8. And so the equation in blue is y equals mx plus b. So similarly, the green line will pass through these 2 points. So I'm going to find its gradient and y-intercept. So using y2 minus y1 over x2 minus x1, this time I get the gradient is negative 1 over 16. So substituting into y equals m times x plus b, I get this equation here. And so I get b is positive 10 over 16, or 5 over 8. So the equation of the green line will be y equals negative 1 over 16x plus 5 over 8. So I'm going to rub out this working out. Please pause and copy down if you need. So our PDF is actually in 2 parts. One function for x between 2 and 6, which is this line here, and another function for x between 6 and 10, which is this function here. So this here is our PDF, but it's in 2 parts. It's this function for x between 2 and 6, and this function x between 6 and 10. So if I want to find the probability that someone takes between 3 and 7 seconds, really what I'm after is this area between 3 and 7. I want this whole area in here. Now, what I could do is I could integrate this function from 3 to 6, this function from 6 to 7, and add them together. There's nothing wrong with doing that, but there's an easier way because this is a triangle. What I could do is I could find this area here, which is just a trapezium. So that would be the area from 3 to 6, and then I could find the area from 6 to 7, which would just be this area in here. So it'll be easier to do this without integration. So let's first find the area in black. I'll just call that A1. So it's a trapezium. The height is 3, so it's h over 2, and then I need to go A plus B. So I know that this height here is a quarter, but I don't know this height here. But that's really easy. Now I have the function, and this is why I found the function. I can just substitute x equals 3 into this function. And what I actually get is that this height here is 1 over 16. So that will be the area of the first trapezium. So that just gives me 15 over 32. So now I'll calculate the second area. So once again, I need to know this vertical distance here. That's why I needed to know this function. So this occurs when x equals 7. So I'm just going to substitute x equals 7 into this function here. So it turns out that I get 3 over 16 for that. This is the y value when I've substituted x equals 7 into that. So the area of this trapezium here, the second one, will simply be height over 2 times A plus B, the sum of the two parallel sides. Turns out that gives us 7 over 32. So the total area between x equals 3 and x equals 7, I just add these two together, I get 22 over 32 or 11 over 16. That's the probability someone will take between 3 and 7 seconds. Again, I could have used integration for this, but it was probably easier using trapeziums, just as it's easier using rectangles when dealing with a uniform distribution. You can use integration, but we probably want to avoid it if we can. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.